This tutorial is going to show you how to complete the square when you're given an equation in standard form and it involves fractions. So it'll just walk you through the steps to make sure that you're okay working with fractions and that again you have a clear understanding of how to complete the square and all the steps that are involved. Well, if we were asked to express this function in vertex form, we might think right off the bat, well, if I knew the vertex, I could quickly write vertex form. And so you might think, well, what if we graph this? And here's the graph of this function. And I think it's worthwhile pointing out that if we look at the vertex, we can clearly see there's the vertex right there. And this doesn't sort of land on any nice grid point. It's not lining up with any of the integer grid lines, so we know that this is going to turn out to be some sort of rational value, a fraction. We do, however, see this plus 4, which is the c value on the end of standard form, and we can see that that clearly identifies the y-intercept. So we know the y-intercept, it's just a matter of we don't know the actual coordinates of the vertex. So we can't just sort of graph this and then write vertex form right away. So we're going to have to do a little bit of work. Okay, well, what are the steps that we're going to be walking through? Well, here's the steps. The first thing we're going to do is we're going to factor out the a value that is sitting in front of the x squared term. So I'm just going to rewrite this equation, and what we're going to pull out is the negative 1/3. And I factor that out, and the important thing to note is that we are only going to factor that 1/3 out of the first term with the x squared and the second term that has the x. So just the terms including the variable x. Those are the only two that we're going to work with. And we're going to factor them out and we're going to include them inside the brackets here. The plus 4 for the meantime is just going to sit on the end outside. Okay, so when we factor out the a value, what's left inside the brackets? Well, 1/3 x squared, when we divide that by negative 1/3, we are left with x squared inside. And then we have to take the second term, which is 1/2 x, and divide it by negative 1/3. Well, just to remind ourselves of how to work with fractions, I'm looking to take 1/2 and divide it by negative 1/3. And I know that that is exactly the same as asking for 1/2 multiplied by the reciprocal, 3/1. That turns out to be top times top, -3, bottom times bottom, 2. So this -3/2 is what remains in the second term. And there we have factored out the a value. I can always check my answer, right? As we're going along, I can always take negative 1/3 multiplied by x squared, and that gives me negative 1/3 x squared. And I could say negative 1/3 times negative 3/2 x, and I would wind up with positive 1/2 x. So performing these checks as I go along ensures that I'm on the right track. Let's look at step 2. Step 2 instructs me to take half of the middle value, that would be this negative 3/2, and square it. Okay, well, to take half of something, I just multiply it by a half. So I'm going to take the negative 3/2, there's the middle coefficient, and I'm going to multiply it by 1/2. Okay, well, top times top, bottom times bottom, that gives me negative 3/4. And then square it. Okay, well, when I take that and I square it, that gives me negative 3 squared is positive 9, and 4 squared is 16. So this 9/16, this value here, is the value that will turn these first two terms into a perfect square. Okay, so it's the missing constant value at the end. So let's put that in. So I'm just going to say negative 1/3, and then inside these brackets, I'm going to have x squared minus 3/2 x. Then I'm going to add 9/16, and immediately subtract 9/16. And by subtracting it right away, the net change is 0. So I'm not actually changing the equation in any manner. I haven't broken any rules here. I added 9/16, immediately subtracted it, so the net change is 0. Well then, how have I helped myself? Well, if we now just focus on these first 3 terms, there is the perfect square. So that perfect square can now be expressed as something in brackets, x, and then a term. And the question is, well, what do I place in there with the x? What's the term that's going to go in there? And all I'm going to do is look over here in step 2. We took the middle coefficient, -3/2, and we took half of it, and that gave us -3/4. That is the value that belongs right in there. Okay? All right. The rest of the equation stays exactly the same. So this equals -1/3 out front. Now, I had round brackets, one set of them in the previous step, and now I've got these orange round brackets. So I'm just going to switch. I'm just going to put some square braces in because I've used the round ones. And that allows me to just make sure that this -9/16 is still tucked inside the brackets. +4, still at the end. So we've taken care of writing the perfect square. The perfect square is that x minus 3/4 squared. There's the perfect square. Okay. Step 4 now tells us to distribute the a value back into those square braces, and we'll remove those brackets. So if we look inside these black square braces, we can see the perfect square is sitting in there. That's one term. And the green, -9/16, is the second term. So we're going to multiply this 1/3, the -1/3 in, and it's going to actually get multiplied into both terms. That will remove those black brackets. We're left with -1/3 times the first orange term, which is x minus 3/4 squared, and then we'll multiply the -1/3 times -9/16. When you multiply fractions, top times top, bottom times bottom, we've got a negative times a negative, so the result is going to be positive, and we're going to end up with 9/48. The brackets are now gone, and this leads us on to step 5, which tells us to collect these terms. And the terms we're going to collect are the 2 terms on the end. Okay, well, to collect them, they're both fractions. 4/1 is a fraction that's equivalent to 4. But we need a common denominator. So you might go looking for 48 as the common denominator, but I'm going to suggest that we can make our life a little simpler if we go ahead and -3/4 squared, if we realize that 9/48 is actually the same as 3/16. So I'm just reducing this fraction before I go looking for a common denominator. Now I can put 4 over the common denominator of 16, and that is 64/16. And then our last step is to combine those 2 fractions, add them together. We have -1/3 and x minus 3/4 squared and 67/16. And if we can reduce this fraction, or any of our fractions we do, we can't reduce 67/16. That's the best we can do. So there we have accomplished our goal, which was to express this function in vertex form. And I can clearly see that the vertex will be at, well, where is it? Well, it's at +3/4 for the x term, for the x coordinate, and then the y, or optimal value, is 67/16. So if you recall the graph that we took a look at the start, it showed us a picture of the function, and we found that the vertex didn't land on some nice points. So if we take another look at it, well, here it is. And if we draw our attention to first, there's the y-intercept right there, and that comes from the standard form. But here, if we write what our vertex was, the vertex we said was at, and it was positive 3/4, and then it was 67 over 16. Well, there's our positive 3/4, and if we take 67 and divide it by 16, we actually get 4.1875, rounded, gives us that value there. So by starting with standard form and then completing the square, we can very quickly work through, and as long as we're careful with our fractions, we will end up with an accurate, precise value. And what I don't want you to do is I don't want you to go ahead and change these values to decimal values. Just leave them as improper fractions in the case of the y-coordinate, and just leave them, as long as they're reduced, leave them the way they are. Okay? Now, just as a final exercise, if I show you this graph of the function again, you'll notice that here down in the bottom we have some values here. Here's the one root, which is negative 2.794, and the other root is 4.294. And again, those are not nice integer values. Well, how could we find out those roots if we were interested in finding them? And what I want you to do is just a final exercise, is take the equation in standard form and use the quadratic formula to find the actual values of these roots, and make sure that you can use the quadratic formula effectively and come up with the correct roots. Okay, so there's your homework that goes along with this video. And again, completing the square, a nice easy process to turn standard form into vertex form.